Hey, in this video we'll be talking about template functions, a way to start us off with templates, this idea of making generic code structures that can work with any type of data. So, I'm in Visual Studio and I want to make a function. So let me write some code to start us off. Let's say we have a couple of floats. And maybe we want a result. Let's say we want to get the greater of these two values, and it doesn't matter what values they are. Just imagine we have some values. So I could say, like, if A is greater than B, then C is A. Otherwise, C gets B. Okay? And then we could go and print that out. The greater value is alright. So I could refactor this and put this into a function, make it more usable, more reusable. Let's call it getMax. We have two pieces of input, the two values we want, and one piece of output, the result that we get. Let's say I'll just use the same variable names, it's not important. And then I can pretty much take this code and just drop it in there. Alright, then I have to return something. Alright, so in my main function, I can use this function now, getMax, passing A and B, and it'll return the value that's the greater of either A or B. Okay, I can make this code a little bit better. C is actually an unnecessary variable here. My result is C, but that means that it could be either A or B here, and I could just return them here. Return A, return B, and then I don't need C at all. There's another detail here. I don't even need this else. I mean, it doesn't hurt to leave it in, but it's also unnecessary because if this is true, I'll return A, and that ends the function early. So there's an implicit else here. Okay, so this function works. It will work for our floats. It will work for other types. So let's try integers. Let's just change this around a little bit. Alright. So it will work for integers, however, it has to do conversions in order to do this. Integers and floats are not the same thing. They're not stored in memory the same way. So when I pass A here as an integer, it needs to be converted into a float, and that takes time. It then reaches the end of the function, and it will convert that value. Well, it's a float now, but I have to convert that value back into an int in order to store it in this variable. And that'll be done automatically, but it's not for free. There's still a computational cost in doing this. So what would be nice, and you can think even further, you can think like, what if I passed in char values in here and they got converted? It would be nice if we could make functions that would work for the int version and work for the float version and everything like that. So I could copy this. I could use function overloading and just make an additional version of this function that just works with integers. But then, do I have to make another version of this function that works for char, another version that works for long, and another version that works for double? It sounds like I'm getting carried away, just so that I can cover all these different types without doing unnecessary conversions. It sounds like something a computer would be a lot better at. So I want to tell the computer, why don't you do it? Do this for me. Create these functions for me, but only if I really need them. So that's what templates are for. With a template, we can specify a generic type. We say, use this type as a placeholder for whatever type I actually end up using, And if I use a type and you haven't generated a function for it, then create a function from this template. So we do that with the template keyword, and then in angle brackets, type name, and then a placeholder type. So I'm going to use T, capital T. It can be any identifier that you want. And then I go through my function and replace any types I'm using that I want to be replaced with that type. So if I use this with integers now, this is an instruction for the compiler to generate a function that uses int in place of all of these t's. If I used floats, it would create one that has float in place of all the t's, and so on. So it only creates the ones that are necessary. And that means that technically I'm not even really defining a function here. I'm defining a template function, a template, instructions that tell the compiler how to create functions, actual functions. So this is pretty cool, pretty powerful too. And we're going to see in the next video how we can take this idea and apply it to classes. There are a lot of other ways that these templates, this generic programming is very useful. And you can see it too in C#, though they didn't take all of the features that C++ has. There's a lot of detail and complexity and power that C++ exposes through its template system. All right, I'll see you in the next one.